Hello everyone, my name is Sara and I'm an independent design engineer. Over the last few years I've made quite a few mistakes and learned quite a few things about building more accessible and inclusive interfaces and products. And in this talk I want to share some of the most relevant and useful lessons that I've learned and share a bunch of tips and tricks with you that you can learn and start using in your projects right away to make them a little more accessible. But before we dive straight into the meat of this talk, I want to share one of my favorite moments of inspiration with you that I had when I was still starting my journey as a developer of the web. I entered the world of web development back in 2013. In 2014, the Adobe Web Platform team were developing a set of new CSS technologies and actively working on pushing them to the browser that would enable designers and developers to create sophisticated storytelling experiences on the web. Some of those technologies include CSS shapes and exclusions, CSS regions, clipping and masking, blend modes, custom CSS filters, also known as CSS shaders, and more. To demonstrate the capabilities of these then new and upcoming technologies and showcase how they can be used to enhance the user experience on the web Web Platform team wrote a series of articles and created a bunch of demos and applications leveraging these new CSS features. The team created wonderful demos using the technologies that they were working on, and they were all very creative and inspiring, like the demo that you're seeing here, showcasing how CSS shapes and animations applied on scroll can enhance visual storytelling and create a creative and engaging experience in the browser. But out of all the demos, one demo stood out for me the most. That demo was a web application created in partnership with the Food Network called Cupcakes. Cupcakes was an iPad app, and the creative team at Adobe decided to bring this application to the web. In addition to using almost all of the CSS features that were in the works, masking, clipping, 3D animations, shapes, and regions, creating a visually pleasing experience, the application was optimized for the context in which it was going to be used: cooking in the kitchen. The following is a clip from a longer video in which CJ Gallman, a creative developer at Adobe, demos the application and showcases all the new CSS technologies used in it. In this particular part you're going to watch now, CJ talks about the more practical features that they added to the application in order to make it more practical.
Because this is a recipe application, most of the time people are going to have their hands busy or dirty while they're actually using it. So we wanted to create a way that you could navigate the application without actually having to touch your computer and get it dirty. So what we did was implemented voice navigation. And let me show you how this works. You can actually click this little button down here and watch as I talk into the application, it'll actually navigate between sections. Go to Cupcakes. Vanilla cupcakes. Recipe. So you can see how that creates the ability for us to navigate the application without ever having to touch our computer. We can also make use of other hardware, like the Leap Motion device, which allows us to use gestural input when navigating our computer. So I can just input the device, and it instantly recognizes it. And we're using CSS regions to break up our content into different slides, but instead of having to touch the device to navigate, we're actually using the Leap Motion, so you can use gestures to actually swipe through the content and continue cooking. Another thing we can do is add more features to our application, like a timer that allows us to count down how many minutes we have left when cooking our cupcakes. Or adjust the quantity. For example, if we want 20 instead of 12 cupcakes, I can know exactly how many tablespoons of unsalted butter I'll need. A great feature and challenge of the web is that it fits on every screen, so we really need to make our content responsive.
The application was built with the user in mind, and that's what made it so feature-rich and so practical. To date, I still remember how incredibly inspired I was when I watched the video. I was fascinated by the possibilities of what I could do and create using web technologies, by the idea that I'd have the ability to use tools we have at our disposal to design and build solutions that serve people and make their lives better. CJ could have created this application using cool, modern CSS features without adding that voice and hand gesture support, but the experience wouldn't have been as inclusive nor as practical. But by doing so, he created a more inclusive experience, a more human experience, and above all, a more memorable experience. One so memorable that I still draw inspiration from it today, a little less than 10 years after its creation. And by the way, Navigating a web page using voice commands is actually more common than we think. Sometimes it's even a necessity for some users. I'll touch more on that later during the talk. Unfortunately, today, thinking about people's needs, contexts, abilities, disabilities, and preferences and how we should be creating experiences that work for everyone often sounds like a burden and a creativity killer. But this application is living proof that this doesn't have to be the case. Oftentimes, constraint fuels creativity. I really like the way Microsoft expresses it on the inclusive design reference, a great resource created by Microsoft to encourage and push inclusive design as an approach to creating experiences on the web. It says, expanding interactions to become more inclusive and seeing diversity differently as a dynamic inspiration for creatives. Emphasis mine. In order to design inclusive experiences, we need to get familiar with how our users use our interfaces and consume our content, how users in different contexts and abilities navigate the web. The Cupcake app was an example of a context where the user would have some difficulty touching the screen with their dirty hands. People could be browsing the web in different contexts that affect their ability to navigate and use our interfaces. Some people are born with permanent disabilities that fundamentally change the way they perceive the world and the web. Other people might be browsing the web with a temporary disability caused by an accident or a temporary health situation. And there are people who are limited by situational disabilities, like being in a noisy room or in a low lighting condition. Over 1 billion people live with some form of disability. Each and any one of us could end up with one form of disability or another at any point. After all, we're all just temporarily abled. Building inclusive experiences with all the different user contexts and disabilities in mind might feel like a lot of work, and it often is. But as with everything, the more you do it, the more efficient you get at doing it, and the less of an effort it takes. In this talk, I want to share some tips that are small and fairly easy to implement, but can have a big impact on accessibility and inclusivity of your products. The good news is that you can cover a lot of ground and create far more resilient, inclusive, and accessible experiences by starting with a solid foundation. And the foundation of every accessible website is semantic HTML. Semantic HTML is the universal language that all devices accessing the internet understand. It is the language that you use to communicate your content to these various devices, including but not limited to browsers, reading apps, screen readers, smartwatches, smart refrigerators, cars, and more. HTML by nature is semantic, or in other words, it is descriptive and provides meaning. Each HTML element describes the type of content that it presents. So using semantic HTML essentially means using the correct HTML elements for their correct purpose as much as possible. If you have a heading, you use a heading element. If you have a paragraph, you use a p tag. By using correct elements, your document content will have conveyable structure and meaning. A sighted user can get a clear structure of a page by quickly scanning it. They can get a clear idea which content is the main content, which content is complementary. Headings, section blocks, and white space and image sizes are used to indicate importance. A sighted user can get a clear skeleton of the page just by looking at it, but a visually impaired user cannot. They will often rely on screen reading software to convey content structure and meaning, and screen readers rely on HTML semantics to create a navigation that the user can use to navigate more efficiently. In this talk, I'm demoing how a screen reader user, specifically VoiceOver on macOS, can navigate a web page using what is known as a rotor. The rotor is like power commands but for screen reader users. It increases their efficiency and facilitates their browsing the web. Inside the rotor, there are several menus that the user can use to navigate. You have a headings menu that allows you to jump to a particular heading on the page. So the headings menu lists all of the headings on a page and allows you to choose which one you want to jump to. In addition, you have other menus, including the landmarks menu, which lists all of the landmarks on the page, like banner, which is the header. You also have the navigation, search, main, etc. There are also other menus, including the links menu, which contains a list of all of the links on the page, and once again, you can choose to skip to them. There is also the form controls menu, which would contain all of the form controls on the page so that the user can also navigate and jump to them. Using the rotor, and if the document is using semantic markup and proper sectioning elements such as nav, header, main, footer, aside, the user can move from one area of the page to another without having to go through the content in each section. and it is very important for them to be able to do so. But the document structure in the rotor is defined by the document structure in your HTML. So if you don't provide a heading, it won't show up in the rotor, and the document hierarchy for screen readers will be affected. If you don't use a landmark, it won't show up in the rotor, and the user won't have the ability to jump to it. Now, this sounds pretty straightforward. HTML5 provides sectioning elements, and we have headings with heading levels that can be used to define a document structure similar to the visual hierarchy sighted users can get. Use these elements, and you should be good to go. But things aren't always as simple as they sound. What if the design spec says that you don't have a heading somewhere, and a sighted user is able to infer page structure from visual elements like spacing, for example? In a project I worked on last year, I had a couple of interesting scenarios like these. First, the simpler scenario. I had a few page templates that simply didn't have any headings associated with the main section of the page. A page listing a series of articles like this one had a description on top for sighted users, and then the list of articles. The sighted user can tell what the articles are about and how they are related to each other using the description and the content in the header. I built the basic structure of the page, but when I navigated the page using the rotor, in this case I'm using VoiceOver on macOS, I noticed two problems. The headings menu included a list of all the headings with no context, starting with the heading level 2, skipping the heading level 1. There is no clear correlation between these headings, that they belong to a specific section or title because that title is missing. And navigating using the landmarks menu, and this was in Chrome, I got all the main landmarks looking good except for the main content area. VoiceOver on Chrome was using the first paragraph of text it found as a label to the main area, which is of course very bad. VoiceOver will need to read the entire paragraph before it announces that this is the main section. Now, the fix in this case was simple. Both navigations were broken because the main section was missing a heading. Since the design doesn't have a visible heading, I added a heading that's only exposed to screen readers. Now, we'll talk about hiding content accessibly in the next section, but for now, suffice it to say that this class, the visually hidden class, applies styles that hide this piece of text visually while making sure that it's still accessible by screen readers. Adding this heading fixes both the headings and the landmarks menus in the rotor. Now, adding a title to sections where one was missing is straightforward, but then there were also instances where it looked like there was no heading, but in the reality, there was one. Similar to the other templates, but also slightly different, were the tag and category page templates. We had a header at the top, a paragraph at the beginning of the page, and then content in the sidebar and the main area containing a list of articles or resources sharing the same tag or category. Looking at the design, I visually divided the main elements on the page into 3 parts based on how they would be laid out. So this is visual representation, not a semantic one. This is not code. Now, because I was familiar with how screen reader users navigate a page, and because I've made a habit of always thinking about the content from a markup and semantics perspective, I knew that navigating the page with the rotor using landmarks and headings, something weird was going to happen, and it is because of this little part here, and the heading inside of it. If a user is navigating using headings, this heading would show up on the headings list as resources tagged with. It's incomplete. Resources tagged with what? Answering this question provides me with the first step to fix the problem at hand. The generative word is part of the heading, even if it is styled to look like it's not. Now that I have a complete heading, the next thought was, okay, so what is this a heading for? A heading creates the expectation that content will follow it, but in this case there was no content. Well, not in the sidebar. This heading describes the content on the right. In the main section, it describes the list of articles. These articles on the right are all resources tagged with generative. In other words, this heading should not live in a sidebar, it should be part of the main section of the page. And since it is the main title of the page, it should be marked up as such, meaning that it should be a level 1 heading, even if it is visually styled to look smaller, like an H2 or an H3. With all that taken into consideration, I visually separated the heading from the sidebar, and the resulting markup looked something like this. So somewhere in the code, if I remember correctly, due to layout requirements, I placed the heading outside of the main element so I needed to let the screen readers know that the heading exists elsewhere by linking it using aria-labeled-by. Also, aria-labeled-by fixed the VoiceOver bug that I had in Chrome, where the first paragraph was used as a label for the main area. Now when I navigate the page using VoiceOver, the Landmarks menu displays all of my landmarks properly, and the screen reader associates that heading with the main landmark. And the Headings menu displays the proper document structure and hierarchy that demonstrates the relationship between all the articles in the main area and categorizes them under the generative tag. Now, without thinking about the importance of document structure and taking that into account when writing the underlying code of the page, the markup would have been much different and much less accessible. So the main takeaways from this section are: use HTML5 landmarks, provide headings where needed and follow headings order on the page. Don't skip headings. If a heading looks small, use the appropriate heading level in the HTML and style it to look smaller using CSS. If a heading is to be visually hidden, provide one for screen reader users. A survey of screen reader users a few years ago showed that 80% of respondents will use regions to navigate, but they can only do so if you choose to use them instead of wrapping everything in divs. When you don't use semantic HTML elements, you take away your user's ability to navigate your content, making it frustrating and inaccessible. Now, we mentioned earlier that the rotor contains different menus, one for headings, landmarks, and more. Among those menus is a links menu and a form controls menu. Knowing how a screen reader user might navigate a page opens up the possibility to optimize our interfaces and improve their user experience even more. A common design in e-commerce websites is displaying a list of products on a page, each with its own Add to Cart button, allowing the user to quickly add items to their cart. To demonstrate, here is the Chili's Bottles website showcasing a list of beautiful, reusable bottles. Each bottle comes with its own Add to Cart button and View link. The View link, as you might expect, takes you to the product details page if you want to learn more about each bottle. If you navigate this page using VoiceOver and use the Form Controls menu, you'll get a list of all the form controls on the page, including the Add to Cart buttons. Quickly scanning these buttons, you can tell that they provide very little value, as there is no way to tell which product each button corresponds to. How do I know which button I want to go to and press if I don't know which product it corresponds to? I don't want to be adding products to the cart that I don't want, right? So I bet you may have already guessed one way we could improve the navigation: by adding screen reader only text. So the solution could look something like this. You would add the product name in the middle of the button text. So it says add this particular bottle to cart. You include the product name in the button's text string. So now when the Form Controls menu displays the list of buttons, each button is clearly labeled to indicate which bottle it is referring to. This is indeed a very good solution for a screen reader user navigating using form controls, but you do not want to do this, because even though it improves the experience for some screen reader users, it excludes users of other assistive technologies and makes these buttons inaccessible to them, and a pain to use. More specifically, inserting visually hidden text in the middle of a visible string of text or a visible label on a button prevents the user's browsing and navigating using voice commands from interacting with the button. A popular example of voice recognition software used to browse the web is Dragon Naturally Speaking. It is software that allows you to use your computer and browse the web using voice commands. Such software is useful for a lot of people, including but not limited to people with disabilities who can't use their hands, for example, or power users who want to get things done faster, because voice dictation is usually faster than typing. Now, seeing it in action is the best way to get a general idea of how it's used and therefore how we can improve our interfaces. So to quickly demonstrate how it is used on the web, Level Access created a video demoing its usage to fill out a form on a page. This video is a short clip from their video in which you can find on YouTube. A quick aside here. When the narrator says go to sleep or wake up, he's basically pausing Dragon and reactivating it by telling it to sleep and wake up.
Click full name. Thomas Logan. Press tab. Go to sleep. Now I have saved a command for my email address so that I can easily input it into this field. Wake up. My work email address. Click radio button. 1. Click checkbox. 1. Press tab. Press tab. Go to sleep. When Dragon is in dictation mode, I am able to speak any type of text, and it will try to translate as best as it can. Wake up. Please let me know when the North Carolina t-shirt becomes available. Period. Press tab. Go to sleep. Now I have given focus to a custom control. This control has been made perfectly accessible, so I can easily control it with my voice, with the keyboard, or with the mouse. I'll show you how all three options work. Wake up. Click Next State. Click Previous State. Press right. Press right. Mouse grid. 9, 1, 4, 6, 6. Click. Go to sleep. Now you can see from those three options, obviously the best option is having a nice name for the control on the screen, because then I can speak it using natural language. Additionally, using the keyboard commands is a nice way to be able to perform functions that don't have a logical speech command. Lastly, the mouse grid was just used to demonstrate to you all how people have to use this technology to interact with software that has not been made accessible. As you can see,
When a Dragon user wants to select a form control, he speaks out the visual label of that control. This is one of many reasons why visual labels are important in user interfaces. So when we have a series of Add to Cart buttons, a Dragon user will speak the label of the button in order to interact with it. This is why adding text in the middle of the string makes it inaccessible. The content in the middle of the string would break the visible name. The user would be telling Dragon to interact with a button whose label is not what it visually appears to be. Now, we still want to improve the experience for screen reader users though, but we can't insert the product name into the button's visible label. We can't fix the experience for a group of people and end up breaking it for another group. Challenges like these make you scratch your head and think of alternative solutions, and I like that. As it turns out, there's a middle ground here. We can still add the product name to the button, improving the screen reader user experience, without breaking the visible name of the button by appending it to the end of the button's name instead of inserting it in the middle. So it looks something like this. By appending the text to the end of the visible name is left intact, and the rotor menu will show a list of Add to Cart buttons with the name of the products that they are referring to. As for voice control users, when they say click Add to Cart, Dragon is going to label the buttons that start with Add to Cart. It's going to label them with numbers, like we saw with the checkbox and radio button examples in the video, and then the user can speak out the number of the button that they want to click. This works because voice commands work by saying the name of the input that you want to interact with, as long as the name is not broken in the markup. So, a good rule of thumb is, whenever adding additional information to a visible label, it must come after what's visually present. Knowing how voice control users navigate the web can also inspire more visual improvements to our components. If the user needs to see a visible label to interact with a control, then what about controls that don't have any visible labels? What about components that have label-less controls, such as dot navigations, that we usually see in sliders? If a user wants to interact with the dots in a dot navigation, they can't speak their accessible name because they don't have a visible one that they can see. So they are left with two other ways to navigate, using voice commands to tab through the control, or using the mouse grid, which is the most tedious and least favorable option. It should be obvious by now that the best practice is to always have a visible label for UI controls. But if that's not possible at all, then the next option is to show a label on focus. The image you're looking at is a screenshot of a testimonial slider that I built for Prismic, the headless CMS company, as part of their Slice Machine project. In order to make the dot navigation a little more accessible, I added visible labels that would show up as a tooltip when the dots receive keyboard focus, something similar to this. Other visual elements that would be more accessible and associated with a visible label are icons, or icon buttons to be more specific. Similar to the dot navigation buttons, if you can't add a visible label, try showing one when the user interacts with the button. And try to use icons that are universally understandable, otherwise voice control users would have a hard time operating it. Speaking of icon buttons, I want to go a little bit deeper into other aspects of making them accessible. Icon buttons are a great example to show the different ways that we can approach a solution, and we'll cover the different ways to hide and expose content whilst making sure that it remains accessible to screen readers. Knowing how to show and hide content with accessibility in mind is a fundamental piece of knowledge for building accessible user interfaces. But first, a quick heads up. You can inspect how a button, or any other element for that matter, will be exposed to a screen reader using your browser's DevTools. Here I'm showing how a simple button with a piece of text inside of it will show up in the Chrome DevTools as an object with a number of properties and attributes. The two most important attributes of a button are its accessible name and role. These two attributes tell a screen reader that this is a button. They tell a screen reader user that this is a button and what the label of the button is so that they can interact with it. The DevTools also show you where it got the accessible name of the button from. In this example, the text content of the button is used as its name. The button role is derived from the semantics of the button element. If you use a div to create a button, which you should never do, it won't be exposed as a button anymore to screen reader users unless you add ARIA attributes to explicitly expose it at one. But even if you expose a role using ARIA, it's not enough to make the button accessible. If you use a div, you'll have to implement all of the native button functionality using JavaScript. But why would you want to do that when the native button element provides you with all of that for free, right? Now, using VoiceOver on macOS, this button will be announced to the user by its name followed by its role. So it would announce send message button. Pretty straightforward. So how is an icon button exposed and announced? What name does a screen reader use for the button when there is no text in it? We need text to label the button, so we need to add that. Just like with the screen reader only headings, we can provide text for screen readers only. We hide that text visually and make it accessible to screen readers. There are quite a few ways to hide content in CSS and HTML, and more than one way to expose content to screen readers to use as an accessible name. The visually hidden class name that we saw before is only one way. So there are currently 4 different ways to hide content using CSS. Using the clip path property with a value and set 100%, using opacity and setting it to 0, using visibility and setting it to hidden, and using display and setting it to none. Out of these 4 ways, display hidden and visibility hidden and display none will remove the element that they hide from the DOM and the accessibility tree, thus making it completely inaccessible. In addition to the CSS properties, we have HTML attributes that can be used to hide content visually and from screen readers. The first attribute is the hidden attribute. It is the HTML equivalent of CSS's display none. So the content is hidden both visually and from assistive technologies. And it's useful for hiding content when CSS is disabled, such as reader modes. Similar to the hidden attribute is the ARIA hidden attribute. The ARIA hidden attribute determines whether an element it is applied to is hidden from screen readers or accessibility APIs. If it's set to true, it's hidden. If it's set to false, it's not. It's useful for hiding decorative or duplicative content. Example, decorative icon sitting next to text. When a button already contains a visible text label, the icon sitting next to it becomes irrelevant to screen readers because they already have an accessible name for a button. Of course, that is assuming that the icon and the text label have the same meaning. So, for example, if you have a menu button that has a label and a menu icon, you can hide the icon by setting its ARIA hidden value to true. Additionally, you can see that I'm using the focusable attribute and setting it to false. What this attribute does is essentially make sure that the SVG cannot receive tab focus in IE and older versions of Edge, because otherwise the SVG will be focusable and have its own tab stop, thus resulting in 2 tab stops for the button. So ARIA hidden can be used to hide content from screen readers while keeping it visually visible. What if you want to do the opposite? What if you only want to hide something visually? Most of the times when you need to provide text for screen readers only, you'll want to hide it visually. For text, emphasis on for text, the most common way to do so is to use a utility class. So the visually hidden class, also sometimes called SR only class, screen reader only class, it's a utility class that essentially shrinks an element into 1 pixel square, hides any overflow, and absolutely positions the element to remove any trace of it from the normal document flow. Okay, so we can hide elements visually only, we can hide elements from screen readers only, and we can hide elements from both. Let's see how these techniques can be used to create accessible icon buttons. Keep in mind that we want our buttons to have an accessible name, so let's see how we can approach that. The first way we can create an accessible name for an icon button is by providing screen reader only text using the screen reader only or visually hidden utility class on a piece of text inside the button. Since the text is exposed to the screen reader, the icon becomes redundant and irrelevant, so we hide it using aria hidden. And once again, focusable false. So I have my button, I have my icon, which is visible visually. I have my screen reader only text. Since the screen reader already has a label and it already has the role implied from the button element, the icon is redundant, so we hide it from screen readers. If we inspect this button in the accessibility tree in the DevTools, it shows up as a button, and the accessibility API is using the text inside the button as an accessible name. Now, the second approach is a very common and a very popular one. Once again, we have a button that contains our SVG icon, but here we're providing the button name using aria label. The aria label attribute is used to provide an accessible name to the element that it is used on. You provide the attribute with a string of text, and that string of text will be used as the name for the button. A couple of things to note here. You don't need to add the word button to the label because the screen reader will announce the role of the button right after its accessible name. So this button will be announced as menu button. The contents of aria label will override the contents of the button. So even if you have a piece of text inside of the button, the accessibility API will use the text inside of aria label as an accessible name. And the last thing to note here is that the content inside of aria label is not translatable. So if you have an application where you're providing the accessible name of a button inside of aria label, and a user uses translation tools in order to translate the UI of your application, they will not be able to translate the label of the button when it is provided inside of aria label. Something to keep in mind. So if you inspect this button in the DevTools, you can see that it is exposed again as a button with an accessible name derived from aria label. The third technique combines the first and the second one. You have text that you expose to screen readers inside of a span here, but you expose it using another aria attribute, aria labeled by. Aria labeled by is similar to aria label, except that the accessible label it exposes is derived from the contents of the element that it points to, not from its own value. So, in other words, aria labeled by takes the ID of another element, in this case our span, as a value, and then the text content of that other element will be used as an accessible name. In this technique, we're providing the name of the button inside of a span, which we are hiding using the hidden attribute. This technique has two notable advantages over the previous two. You don't need CSS to hide the text visually. The hidden attribute is taking care of that, so the text will always be hidden even when your CSS isn't used. And the contents of the span are translatable, unlike the contents of aria label. This is my go-to technique for adding an accessible name to icon buttons. Now, some of you may be wondering, how is this technique accessible if the hidden attribute removes the element from the accessibility tree? Isn't it supposed to make it inaccessible? And that's a very good question. The answer is simple. Even though the hidden attribute hides an element from screen readers, we can still expose it to them by referencing it inside of aria labeled by. Once again, if we inspect this button in the DevTools, we can see that it's exposed as a button with the accessible name derived from the element that aria labeled by is pointing to. These are the three best ways to create accessible icon buttons. There are two more approaches that I won't cover in this talk because they have their own drawbacks and compatibility issues. But I've written an article on my blog in which I go into the details of each of these techniques that I just covered, as well as the remaining two, and I highly recommend checking it out. So we've covered the basics of hiding and exposing content to screen readers, but there are instances in which these techniques fall short. Specifically, when you find yourself needing to hide a native form element in an attempt to create custom alternative styles. Checkboxes and radio buttons are a very good example of that. In this section, I want to talk about checkboxes, but the principles I'll cover apply to pretty much every other interactive element. In order to create a custom style checkbox, we usually need to hide the native checkbox and then replace it with an image of a checkbox, because we can't style the checkbox itself. But the image replacing the checkbox is, at the end of the day, just an image, a visual replacement of the real checkbox, so the user still needs a checkbox to interact with. A screen reader recognizes an image as an image and still needs a checkbox to expose and announce to the user. Therefore, when we hide the checkbox, we need to make sure that it is still exposed to screen readers. Typically, when we use an SVG image to visually replace a checkbox, which is what I recommend, the code would look something like this. I would have the label wrapping everything. I like to wrap my checkboxes inside their labels because it increases the tappable area, which is useful and convenient for users. Inside of my label, I have my checkbox, I have the SVG that's going to replace it, and I have the text label. At this point, the checkbox is still visible. Before we hide it, we're going to apply some basic styles to the SVG, positioning and sizing it next to the text using relative units so that it scales with the text. And then we style the background and checkmark in their default state and in their checked state. So when the checkbox is checked, the SVG reflects that. We also don't want to forget our focus styles. So when the checkbox receives focus, we show an outline around the SVG checkbox. We're using the CSS sibling selector to apply the focus styles to the SVG when the checkbox is focused. Now, finally, we need to hide the native checkbox. And this is the most important part. Which hiding technique would you choose for hiding the checkbox? I always ask my talk and workshop attendees how they would hide the native checkbox while ensuring that it remains screen reader accessible. Since we want to make sure that it remains accessible, we rule out all of the rules that hide it from screen readers. This usually leaves us with the two most frequent answers. 1. Using the visually hidden utility class, which sounds like the right solution because it hides the checkbox visually whilst still exposing it to screen readers. 2. Move the checkbox off canvas, hiding it outside of the viewport using absolute positioning. This too removes the checkbox from view but does not remove it from the accessibility tree. Now, it's true that both of these techniques hide the checkbox visually and it will still be accessible by a screen reader, but neither of these techniques are inclusive of users navigating by touch. You see, screen readers on Android touch devices give users multiple ways to navigate a screen. One of these ways is exploring by touch. Exploring by touch means that a mobile screen reader can literally move their finger on the screen, on the page, looking for interactive elements. So the way you hide the checkbox determines whether touch screen reader users will be able to find it or not. As you can possibly imagine now, hiding the checkbox off canvas outside of the viewport area will make it inaccessible to them because they won't be able to find it within the viewport bounds as they drag their finger around. Similarly, shrinking the checkbox to 1 pixel will also make it very difficult to find and touch. So while the visually hidden utility class is great for visually hiding static content like text, it should not be used to hide interactive elements. So how do you hide a checkbox inclusively? The answer is hide it visually, but make sure that it is still present where it would naturally be present by default so that touch users can find it with haptics, where they expect to find it. Technically speaking, this means remove the checkbox from the page flow using position absolute so that it doesn't take up any unwanted space visually, and position it within the label, making sure that it's positioned on top of the image that it's visually replacing it. You may need to use Z-index or offset properties depending on your code. You can resize it optionally, and then visually hide it by making it transparent with opacity 0. And finally, since the native checkbox is still exposed to screen readers and we have a visible text label to go with it, once again the SVG image is redundant and irrelevant, so we'll finally hide it using ARIA hidden and focusable false. And this is how you hide interactive elements accessibly. This applies to checkboxes, radio buttons, file input types, and any other interactive input type that you need to hide and visually replace with something else. For a more detailed recap of this technique, you can refer to the article that I wrote about it on my blog. Now, there are many ways people browse the web, too many to cover in this short talk, but there is one little tip that I'd like to cover, one small tip that can help you optimize your experiences for keyboard users so that they too can navigate your content more efficiently. In addition to always ensuring your interactive elements and components have proper accessible focus styles, without which keyboard navigation would be broken, you can use the tab index attribute and ARIA to create a more efficient experience for keyboard users. See, the faster the user can navigate your UI, the better. The less tab steps the user needs to make while navigating, the faster they can get to where they need. Blogs, online magazines, and other publications will normally display lists of articles or posts. Browsing such publications, often you'll notice a familiar pattern in most of these listings. A post entry has a typical anatomy normally consisting of a thumbnail, a post title, author name, post tags, an excerpt or description, and a read more link. Typically, the thumbnail, the post title, and the read more link all link to the same page, the full article page. This means that a keyboard user tabbing their way through the page will have to tab through 3 consecutive links to the same page. An example of that is the Forbes homepage. So posts on the Forbes homepage contain 3 links per post, the thumbnail, the post title, and an icon-only version of the read more link. Clicking on any of these links takes the user to the full article page corresponding to this post. So a user navigating using keyboard practically needs to tab through the same link 3 times in a row to continue navigating to the next post and whatever content comes after. The more posts there are, the longer the tabbing journey will be. Similarly, the New York Times has post listings that have 2 links, also linking to the same page. And then Medium is yet another example with 5 links per listing. If you use a keyboard a lot, you'll probably start to notice how redundant it is to tab through the same link multiple times in a row. When a list of posts is designed with such a structure in mind, it's usually optimized for a sighted mouse or touch user. Such a user would have a generous collection of elements to click or tap. But when a keyboard user needs to tab through the same link through the same link 2 or 3 times in a row, they are slowed down because their journey becomes literally 200% or 300% longer than it could or should be. We can do better. Now, depending on the post structure and anatomy, we could drastically improve the keyboard user experience by preventing some of the links from being tabbable. The implementation is simple. You prevent a link from being tabbed by adding tab index -1 to it, and then you hide the said link from screen readers using ARIA hidden true, because you don't want the screen reader to expose a link to the user that they won't be able to interact with. So the markup for each post in the listing would look something like this. I have my article, I have a link that wraps my image thumbnail, I have a title, another link which is the title, and then another link which is the read more link or the read more icon. I only want the heading or the title of the post to take me to the full article page. So for the thumbnail and the read more links, I add ARIA hidden true and set the tab index to -1. Now, in the examples we saw, the post's excerpt is short and does not contain any links, and there are no lists or lists of tags, for example, following the post title and separating the title from the read more link. When there are several links between the title and the read more link should not be skipped because it improves the user experience. For example, I recorded the process of tabbing through Leah Verou's website, where she shows a longer post excerpt per entry and containing a few links in some cases. Because there are quite a few links after the post title in each entry, see, this is, for example, a description that contains all of these links. The continue reading link here is essential for the keyboard experience. The link is a shortcut in this case to the full articles page now. Had it not been there or had it been skipped, the user would need to tab all the way back up to the post title to visit the full article, which would have been counterproductive. This is an example of when you do not want to use tab index in ARIA to skip over a link because it would worsen the user experience. Each design comes with its own usability considerations that need to be taken into account. In order to improve an experience, you need to test the design using keyboard and with real users if possible. They can usually provide a lot of insight that we designers and developers might miss. A good rule of thumb for similar cases is that if you have multiple consecutive links to the same page, there is probably a chance to improve keyboard navigation by skipping some of those links to reduce the number of tab stops, but there is no one rule fits all. As with previous sections, I have a detailed write-up about this case study on my blog that you can reference for more information. People come in different colors, ages, sizes, backgrounds, abilities, and disabilities and contexts. And this diversity is beautiful, motivating, and inspiring. As web designers and developers, we have the chance to create a web that is inclusive of everyone. We have the responsibility to build a web that does not exclude anyone. As you saw throughout this talk, more often than not, it takes little dev effort to create more inclusive, accessible experiences. I hope this talk has inspired you to approach building interfaces with a more observing eye, a more creative and positive attitude, and a little curiosity to learn more about your users and inspiration to build for the people of the World Wide Web. Thank you.
Fantastic, Sarah. Thank you very much for your time. I have a number of questions. If we could work through a couple of these. If you'd like, I can kind of start at the top here. I think the most popular question from the wonderful folks that joined us today is, what are some tools you'd recommend to preview menus and landmarks on pages?
I don't have personal favorite ones. I tend to use the screen reader that I have on my machine, which is VoiceOver. But there are some really good tools that I typically recommend in my workshops, and one of them is the someone mentioned it also in the channel. It's called the Accessibility Insights for the Web. It's a fantastic. I think it's only available for Chrome, or it's available as a native app in Windows and as a Chrome extension on macOS. I'm not sure, but this is something that I would recommend using.
It's an Edge extension as well.
Oh, great! So we have that as well. Yeah, so I would recommend using that. And then if Axe also provides it, definitely use Axe. I personally prefer to use just the screen reader, VoiceOver, use the rotor to get a clear overview because it's just fast, just a couple of keystrokes and I get that.
Awesome, thank you. Okay, I'm going to do my best. You covered a lot of amazing content and specific examples. So if I ask you a question and the context is lost, I can move on to the next one.
Okay.
So another very popular question is, are there SEO implications for using visually hidden headings?
I don't know what SEO implications means. I've never really worked with or focused on SEO in particular in my work, because ever since I started doing this, I've heard a tip from one of my friends. He said that SEO takes care of itself when you have great content. So if you're putting out great content, you don't really have to do a lot of stuff for SEO. As far as whether or not those headings are going to be exposed, though, they will be exposed. So we're hiding them in a way that just hides them visually, but they're still there and they're still exposed to screen readers and to Google search.
Yeah, thank you. Myself working in marketing, I always like to think of it, if a screen reader can accurately crawl your site, a Google bot probably also can.
That's a good way to put it.
Okay, next question I've got. With the button label screen reader only text, is it better to append the screen reader text at the end or use aria described by to add more context from another element?
With the button label, screen reader only text. So are we talking about the label of the button? Is it better to append the screen reader text at the end or use aria described by? Well, it depends. If you want a string of text, whatever that is, if you want it to be part of the accessible name of the button, then you place it inside of the button. If you want it to be just a description, I've never, for a button per se, I would probably not be using aria described by. So aria described by is a good example for that is if you have an input element, it typically comes with a label. For example, if you have an email address, the label would be email or your email address, then the input. A screen reader is typically going to announce the input, the accessible name, and after that, a short pause followed by whatever you're referencing in aria described by. So aria described by is to add an extra description that is announced after the type of the element and the accessible name. So if you have a slightly larger description, like what the email should be, or criteria basically for the email, it should definitely be a description that comes after, not part of the accessible name. Whereas with buttons, you typically don't have long strings of text. So I would say, if I understand the question correctly, I think that would be inside of the button. And if I can answer another related question,
please,
at this point, because someone asked if it's better to add text inside of the button and then hide that element, or add the label inside of an ARIA label attribute. I would say use the child span, the visually hidden span inside of the button, because ARIA label, there are some issues with translations. So if you have, if the ARIA label contains English text and the user wants to translate the website to Spanish, for example, the text inside of ARIA label is not always translated by all of the tools. So more bulletproof to use actual text inside of the button and then visually hide it.
Thank you, Sarah. There are quite a few questions. I'm not sure if you can answer some of these, but we have some specific questions about the differences in screen reader programs. So one in particular is asking, what sort of experience do you have in working with others aside from VoiceOver on Mac, like JAWS or NVDA? Someone's asking about if you can help clarify maybe some of the differences when testing with them.
I personally don't have any experience because I only have Mac machines. I don't have access to Windows machines, but in this case, I typically rely on the experience of other people. My favorite reference is my friend Scott O'Hara. He comes to mind because he does all of this testing. He shares incredible research. Like, he works with real screen reader users. He tests across a myriad of screen readers, and he shares his research. And there are a lot of people working, not just Scott, there are a lot of people who are sharing their research, the result of their experiences, the result of their tests. And me, just like a lot of other people, we rely on what those generous people share with us. I don't have experience with other screen readers myself.
All right, thank you. Okay, I think, let's see, maybe we can fit in one more question here. Let's see. I hope this is a quick one. What's the best way to describe clickable items for screen readers? Are there links only when used when routing, buttons only for interactions?
Clickable items, that is typically, so interactive items. So that is either going to be a link or a button. The way to describe them is to, first of all, use the semantic elements. So use button for buttons, use links for links. If you absolutely have to deal with code that you didn't write yourself, like if you have to deal with a div that is behaving as a button, then you can use ARIA attributes to tell the screen reader that this is a button. So you would use, for example, role button. But when you do that, you need to just be aware that adding role button to a div does not add the interactivity that the user expects from a button. So you will need to use JavaScript to make sure that that div is clickable and make sure that the user can interact with it using the space and enter keys as well.
Fantastic. Thank you, Sarah, so much for your time.
Thank you.
I really appreciate the massive amount of value and information you were able to give us today. Really, really sincerely appreciate it.
Thank you very much.
Thank you all for joining us.